So it seems that this latest printer is set to compete with injection molding.
Mhm.
So how does the accuracy and quality of parts produced by this printer compare to those produced by injection molding?
My background is mechanical engineering, and one of the things that we do a lot of here is use our own products. So throughout the development of Form 4, I printed on this hundreds of times, mostly for fun, for my own projects. And the best way to answer this, which is not so scientific, we can get to that in a minute, but I think of them as virtually identical in that I don't design any differently for something that could be an injection molded part. More specifically, the tolerances you can achieve on Form 4 with 50 micron XY resolution is really, really tight. And you can basically print just as crisply, as sharply, small, fine features, great surface finish, sort of identical to injection molding. One of the components that we like to talk about is on the mixer here. We have an injection molded latch. A little hard to see in that video, sorry, but that's an injection molded part. And actually, if you print that in our black resin, it is virtually indistinguishable from the true injection molded part. Another part of the printer, sort of comparing it to injection molding, is print speed. Our tool that we use to manufacture this part in mass production, when you take that two cavity tool cycle time and you hold it up against printing a full build platform of those components, it's actually faster on a per part basis to print it on Form 4 than it is to injection mold it. So it's really not just the quality resolution of the parts, but actually the Form 4 can be just as fast as injection molding to output parts, which really changes the game for when you're designing injection molded parts and even producing those components.
Wow. Okay, so are there any specific design considerations at all or limitations that engineers should be aware of when utilizing this 3D printer for manufacturing?
Sure. Every process has, different sets of limitations. I think Formlab sets out to really reduce those with a couple of things. One is the quality I just talked about, but also our material portfolio. So we have, I think over 30 different materials that we can now run on the Form 4, and that opens the design space for engineers when they're designing for manufacturing, other applications, for what you can achieve. And so, just like machining versus injection molding, SLA 3D printing versus both of those, and FDM has different considerations. But overall, I really think that the Form 4 has taken us one step closer to kind of designing without those, especially given you can pick so many different materials that will achieve elasticity or stiffness or robustness, durability. So you can kind of check a lot of those boxes based on what you pick.
Okay, so speaking of the materials, I know that 6 new resins were added to the resin library.
Mhm.
So can you tell our audience about the types of materials that could be used? I know you said there's like over like 30 of them.
Yeah.
So can more than one type be used at a time? Like tell us about the materials.
Sure. Yeah, so the Form 4, just like all SLA 3D printers, is sort of a single material process at a time. But our material library, as I mentioned, is really wide ranging. So that goes from more typical SLA materials. We have our general purpose resins. Those are 4 of the new materials we released that are really changing the game for how good a general purpose material can be. Not only did we improve upon all of the material properties as compared to our previous generation of general purpose resins, so that's clear, white, gray, black. But we also lowered the cost from $150 a liter to $99 a liter. So we're actually delivering more value to our customers while also reducing the cost to run prints, which we've gotten a really great response to, and we're really happy we could achieve that. But it goes beyond just general purpose. We can run true silicones on this printer. We can run ceramics. We can run glass-filled, very rigid resins, flame retardant, high temperature resins. So really the application space gets broadly opened up with that long list of materials. And that's one thing Formlabs really prides ourselves on, is allowing lots of customers to find that optimal material to achieve what they're looking for.
So I'm wondering, are you able to do multi-materials? I know you can only print one material at a time, but are you able to have a part that has multi-materials?
You could certainly combine parts into an assembly afterwards with multi-materials. The printer is sort of set up such that when you run a job, it has to be one material. There's a little post-processing involved with that. So it wouldn't be super easy to combine materials, but you can print. The printer is set up, the ecosystem is such that it's very simple to change materials. So to change materials, you simply remove the resin cartridge out of the back of the printer, and you remove the resin tank from the printer and swap both of those out. And it's just that quick to be able to now run a new material. So on one printer, a given user could run any of those materials I just talked about. So a little complex to do it as part of one part, but it's very simple to produce in all of those different materials with one printer.
So when it comes to cost, what is the estimated ROI for implementing this this printer? And can you elaborate on that?
Yeah, I think that's a tough one to answer in sort of a clear way because everybody's ROI will vary greatly depending on what you're using the printer for. I think what we focus on here is basically a cost per part. We want to reduce the cost per part for our users as much as we can. And so compared to Form 3, we achieve 40% lower cost per part. And there's lots of things that go into this. I talked about the price of resin. That's a big one. But also our other consumables are now longer lifetime and less expensive. So the resin tank is a great example where we expect the resin tank to probably last into the hundreds of thousands of layers in terms of sort of suitable lifetime. And it's much less expensive than the Form 3 resin tank. The same goes for the cartridge as well. So we think about sort of not just the upfront price of the printer, but what it costs to run it. Many of our users are using the printer in very often in their applications, and so that upfront cost actually pales in comparison to what it costs to run the machine. So reducing that by almost half as compared to Form 3 was a big step forward there.
All right, so let's switch it to environmental side of things. Can you give
Sure.
me some insights about environmental sustainability benefits of using this printer?
Yeah, I would say there's a few things to discuss here. The sort of most obvious one, and the one that I'm most proud of, is actually our resin cartridge. This has 60% less plastic in it as compared to our previous resin cartridge. This is the highest volume consumable of using Formlabs products, and so lots of these end up in the trash, and we wanted to really reduce that. You can actually cut this with basically like a box cutter and wash it out to reduce residual resin and make it like sort of very, very clean to dispose of. And then printer reliability is kind of the unspoken environmental impact here. We want to be efficient with the power the printer consumes and the material that goes into it. And so basically you want your prints to come out every time when you run it. And we are sort of on par with Form 3 print success today with Form 4 and going to deliver a lot more reliability with software updates, settings updates for the life of the product to all of our customers. And so that kind of speaks to environmental impact in that you're not going to be consuming as much, whether it's material or power, to get those prints out. And then longer lasting consumables. I mentioned that resin tank. The longer that tank lasts, the fewer tanks you're going through and disposing of. So we really targeted that area. And the last part is the replaceable components I talked about. We don't want to see printers being scrapped and for things that can be repaired. And so making almost everything on the printer either replaceable with the VLU and the LPU, or with consumables, or with subsystems inside the printer that can be user serviceable. We're trying to keep things out of landfills and have broad environmental impact that